And this one has much bigger spread than this one, which is what we want. So that is how we do it. So what did we do? We looked at the deviations from the mean, and then we squared them and did their average. So let's write that down. What did we do? We took the x, what did we say? Xi minus x bar. So we calculated each of those. We squared that. We summed them all up. We summed up all of those after squaring. So we can do that. We can say we summed them up. And then we divided by the number of pieces in the data. That's divided by n. We'll call it n. And that's what we just calculated. And we did that for this one, and we did that for this one, and we found that this one had more spread than this one. So this is called the variance. What we just did is called calculating the variance. So we just let's use just VAR because I don't want to write so much. So I'm going to write VAR for A was approximately 2150, and VAR for B was approximately 720, and we get what we really wanted. I wanted to say that the variance of A is greater than the variance of B. So that is how you calculate the spread, or that in particular, that is how you calculate the variance. Now this is a lot more work than calculating what we talked about was the range, which was just the highest minus the lowest. But the range didn't really work for that, the difference between A and B, because the range for A, if you take the highest and the lowest here, here's A, you get 100 minus 0, and here you also get 100 minus 0. So the range doesn't tell us that they're spread out differently, but this new thing, the variance, does. The variance is this for A and this for B, and that tells us that the variance of A is greater than the variance of B, or that A has more variation in it than B does. Now the last thing is that this number is kind of crazy because it's so big, right? Here's our original data, right? That's our original data. It doesn't seem to be related to this number at all. I mean, this is like much bigger than anything in here, and it's much bigger than any particular spread in here, right? The spread is of this piece, so the first piece from the center is 50 or minus 50, and this one is 50 or minus 50, and this one is 50 or minus whatever. It's not anything like 2100, right? So this is kind of an awkward number to give as the spread. So, and why is it so, why did it end up being so big? Because we wanted to get rid of the negative, the cancellation. We wanted to get rid of negatives. And we chose not to use the absolute value because absolute value was trouble for other reasons. And so we decided to square. And of course, when you square, things get much bigger. So finally, at the end, if we want to bring it down to sort of like relatively numbers that are kind of close to the original data set, what we can do is we can take the square root of the variance. So the square root of the variance of A, or the square root of the variance of B, or whatever, the square root. And that's going to be, okay, so what's the square root of this? I know that 40 times 40 is 1600. I know that 50 times 50 is 2500, right? 40, well, anyway. So this is going to be between 40 and 50. I'll just make a really bad approximation, call it 45. And this one is going to be, I know that 30 times 30 is 900, and 20 times 20 is 400. So it's going to be between 20 and 30. So I'll just make a really bad approximation and say it's 25. So the square root of the variance for A is 45, and the square root of the variance for B is 25. Still, this is considerably bigger than this, which is what we wanted. We wanted to say that this has more variation than this one. And that's what we have here. And these numbers, 45, are much closer to sort of the original size of the original data, and 20 or 25 is much closer to the original size of the data as compared to these numbers were. Now the square root of the variance is what's called the standard deviation. So that's the standard deviation. So the standard deviation tells us again that dataset A was much more spread out than dataset B. Okay, standard deviation. So this the standard deviation for A might be close to 45. I just did a really bad approximation. I got 45. The standard deviation for B was really bad approximation was 25. Okay, so that is what we mean by the variance and the standard deviation. So now we have sort of two or three different ways to measure the variation in data. First is the range, and the second is the variance, and the third is the standard deviation. But the standard deviation and the variance are basically the same thing. I mean, they're calculated nearly exactly the same way. They contain basically the same information, but of course they're not the same. They're different. The standard deviation was 45. The variance was this. But okay, so we can say we have two or three different ways of measuring the spread. So now if you went back to your boss and you had told him or her that the X bar was the same, whoops, what happened? If you had told your boss that X bar for machine A was the same as X bar for machine B, but if you had said this, let's use the standard deviation for A was, what did we say? Well, if you said it was much bigger for, I think it was the other way around. It was for B. This was the original data. Sorry, that wasn't the original data. The original data was here. So A had a much smaller standard deviation than B. So if you had said that the standard deviation for A was much smaller than the standard deviation for B, maybe they wouldn't have bought machine B and you wouldn't have lost your job. Okay, anyway, that's the idea of standard deviation, variance, and range.